Welcome to the Cadmatic Electrical Instrumentation demonstration. In this session, we'll explore how you can quickly and accurately generate fully customizable instrument specification sheets using the DB tool. This workflow is designed to eliminate manual effort, reduce errors, and help your team prepare specifications in a clean, efficient, and highly automated way. Let's begin by creating a new project in the DB tool. We'll start by selecting New Project and then choose a location for the project files. Here, we're creating a new folder named demo_2025_82 so the project stays organized and easy to manage. Next, we'll enter the project name and a short description, for example, Instrument Specification Demo. Once the project is created, we can see the DB tool opens with a completely empty structure. There are no documents, no devices, and no filters applied. Starting from a clean project ensures we clearly understand each step as we build the instrument specifications from scratch. Now let's move to the Import Definition section, where we bring in data from Excel. For instrumentation work, the instrument index is our primary input, and it usually comes from the P&ID. If we're using Cadmatic P&ID, this data can flow directly through integration. If the P&ID comes from a third-party system, we can simply use an Excel export and map it here. We'll browse to our Excel file, and on the right side we can see all the columns already mapped to our database fields. Everything in this process is fully customizable: how we map the fields, how we define the hierarchy, and how we organize the imported devices. After importing, we can see the project now contains 81 instruments. These are automatically grouped according to the P&ID references. For example, under P&ID 11, we have a total of 65 instruments. We can also view them line-wise or device-wise depending on how we want to structure the project. All the details you see, tag numbers, descriptions, locations, come directly from the Excel sheet. We haven't typed anything manually, which helps maintain accuracy and consistency with the P&ID source data. For this demonstration, let's focus on pressure transmitters. We'll apply a quick filter and we can see there are 14 pressure transmitters in total. If we filter with contains further using the T tags, we find 8 pressure transmitters that we'll use for generating instrument specifications. When we open any device, we can confirm all the imported information, tag number, description, location, and circuits. At this stage, we don't yet have additional technical details or product information attached, because that will come from the product model database in the next step. So with the instrument index successfully imported and organized, we're now ready to enrich these devices with manufacturer data and start preparing the specification reports. Next, we move to the product model window. This is where our product database is stored, and where we can attach manufacturer-specific information to our instruments. In this example, we'll use the IFM product database, which already contains 21 pressure transmitter models. Let's open one of these models through the management window. When we click Edit, we can see the complete set of details available for that product, its name, technical parameters, additional notes, and all metadata. These values can come directly from manufacturer datasheets, and we can also import them from vendor websites if they provide Excel or standard structured formats. This product model also includes a symbol, which can later be used when generating loop drawings or I/O drawings. For now, we will assign this product model to one of our pressure transmitters. Once the model is attached, the device automatically reads all related information, dimensions such as height, weight, length, and other technical attributes. If we open the device details, we can immediately see that the additional information section is now populated and the product data is linked. This process can also be performed in bulk. If we select multiple instruments, such as several pressure transmitters, we can apply the same product model to all of them in a single step, using filters or sorting options just like Excel. With the product model data attached, our instruments now have complete technical details, and we're ready to move on to generating the specification reports. Before generating the reports, we need to attach the template. Here, we already have a pressure transmitter template prepared, so we'll select and link it. This template defines what information will be published into the Excel specification. Under the Plates section, we can also see which devices have plates assigned. Only those will receive instrument specification sheets, along with the template details we've configured. Now let's move to the report function. We already have a saved report setting for instrumentation, and once it loads, we can see that 8 instruments are ready for report generation. Each instrument already contains all the imported and product model information we added earlier. To create the specification sheets, we simply select Add to Project Documents. Here, we can also define a prefix for the file names, for example, spec_. Once we confirm, the system generates all the specification documents automatically. Next, we'll open the Document app. After refreshing, we can see that all 8 reports have been created. To make them easier to review, we will filter them with drawing labels. Let's fill in the common labels, such as date, designer name, and revision number. We can update these values individually, but for larger projects, it's much faster to edit them in bulk. So, we'll use the Edit Rows in Excel option. The system opens an Excel sheet containing all the document metadata. Here, we've already prepared the values, so we'll simply copy the updated rows, like author name and revision R1, and paste them into the Excel file. We return to the Document app and use Import Rows from Excel. Now, all the documents are updated with the correct date, designer, and revision details. The final step is to update the reports themselves. Since the documents already exist, we only need to run the update function. This ensures all template fields, such as title block information, revision history, and project data, are synchronized with the latest inputs. With that, all 8 specification reports are fully generated, labeled, and up to date, ready for review or export. After updating the documents, we can open any of the generated reports to review the final output. Here, we'll open one of the deliverables, the instrument specification sheet. At the top, we can clearly see the project name and project description, which were taken directly from the project information. Below that, the data imported from Excel is displayed, such as the tag number, P&ID reference, line number, equipment number, and area. All these fields were captured exactly as they appeared in the instrument index, ensuring full consistency with the P&ID. Next, we can see the technical details that came from the product model we assigned earlier. This includes additional information such as dimensions, ranges, manufacturer name, and model number. All of these values are populated automatically once the product model is linked to the device. We can also see the labels we filled in, like date, designer name, and revision number. These are reflected instantly on the sheet after the update. Additionally, the specification includes a hyperlink to the manufacturer's data source, allowing us to open the vendor page directly and verify the instrument information online. All created and updated reports are saved inside the project folder. From there, if required, we can merge them into a single PDF using a simple VBA macro or an external PDF tool. Here, we have all 8 pressure transmitter specification sheets generated, one for each device. You can see how quickly the entire process was completed and how cleanly all the data was organized. Every template and Excel layout in this workflow is fully customizable, where you want each field, what additional data you want to include, or how the formatting should appear. So whether your team needs a basic datasheet or a very detailed technical document, the format can be tailored exactly to your standards. This process makes creating instrument specification sheets extremely fast. Even if we have 50, 100, or more instruments, we can generate all their specifications in one run, saving a huge amount of manual effort while maintaining accuracy. One of the biggest challenges in instrumentation work is managing revisions. Changes in the instrument index, P&ID updates, or vendor revisions happen frequently, and manually updating specifications can be time-consuming and error-prone. Cadmatic makes this process much easier by allowing us to re-import modified data and automatically update the affected instruments. Let's go through an example. Suppose the instrument index has been updated in the engineering model and we receive a revised Excel file. We'll open our instrument index sheet, apply the same filters we used earlier, PID 11, pressure transmitters, and tags containing PIT. And now we can see the list of instruments. For this demonstration, we'll make a small visible change so the revision is easy to track. In the description column, the devices currently show the word measure. We'll replace this with the word calculate. Once the change is made, we save the Excel file. Now we return to the DB tool and open the Import Definition Management window. We can simply refresh the import, and the system immediately reads the updated Excel file. All the modified values are visible in the preview, including the newly added word calculate in the description. When we run the import, the software compares the new values with the existing project data. On the very first import, new devices are shown in green. However, since we are importing the same instruments, only the changed fields are updated. Calculate now appears in place of the previous description. Instead of marking the item as new, it marks the field as filled, indicating that the value already existed but has been overwritten with the new data. This is extremely useful for tracking which attributes have changed without altering the overall device structure. Now that we've updated the input data, let's also make a small change in the project information. For this demonstration, we'll update the project name and description to R2 so we can clearly see how project level changes reflect inside the specification reports. Once we save these updates, they will automatically appear in the next report update cycle. Now let's return to the Devices section to apply another type of revision. Earlier, we assigned the product model PS317A, but let's assume the vendor has provided an updated model or the engineering team has revised the selection. We'll replace it with a different model. $26.54. If we want to review the details of this model, we can open it in the Management window, where we can see the symbol, name, attributes, and other technical data. Once we add this model to the project, it automatically replaces the previous one, and the system clearly shows which values are being updated. After the change, we can see that all product-related information is refreshed, the description we updated earlier, the new technical parameters, and every field linked to the product model. This reflects typical real-world scenarios where a part number or vendor specification changes during the project. We can also apply this update in bulk. By selecting multiple devices, we can assign the new product model to all 8 pressure transmitters at once. This ensures that every instrument remains accurate and aligned with the latest engineering decisions. Now that we've updated the input data and the product model, let's move to the Document tab to finalize the revisions. Here, we'll open the document list and send the metadata to Excel for easy editing. This allows us to update common fields, such as the date, designer name, and revision, from R1 to R2 in just a few seconds. Once we make the changes in Excel, we return to the Document tab and use the Import Rows from Excel function. This updates all document metadata across every specification sheet instantly. With the metadata updated, we only need to run the Update Report command. We don't need to recreate the reports from the beginning, the system simply refreshes the existing documents with the new values. If we open one of the updated reports, we can immediately see the changes. The revision is now R2, and the new description, calculate, is reflected exactly as we modified it in the instrument index. We can also see that the product model name has changed, and all associated technical data has been replaced according to the new model we selected earlier. The designer name has been updated. Even the hyperlink to the manufacturer has been updated to the new URL. This demonstrates how every section of the report responds to revisions, project information, imported data, product model details, and metadata, all updated automatically with just a few steps. Once the reports are finalized, we can generate PDFs as needed. If required, this workflow becomes extremely powerful in real projects. Whether we're handling 50 instruments or more than 500, we can update all specifications in one go, instead of spending days or weeks manually editing each sheet. It reduces manual effort, minimizes errors, and ensures full consistency with the latest engineering data. As you can see, All specification sheets now contain the new data, revised descriptions, updated product details, new revision numbers, and complete technical information, reflecting every change we made during this demonstration. Cadmatic also provides a document comparison option, which makes it very easy to track changes between revisions. Now, using the comparison tool, we can compare revision 1 and revision 2 side by side. The software highlights the differences automatically. Red indicates deleted values. Green shows newly added values. Yellow highlights fields where the value has changed. Here, we can clearly see which information has been added in revision 2, which fields were removed, and where the updated inputs or product model changes have modified the specification data. This makes revision control extremely transparent and ensures all stakeholders can quickly understand what has changed between versions. With this, we complete the workflow, from importing the instrument index, assigning product models, generating specification sheets, updating revisions, and finally comparing documents. We hope this demonstration helps your organization streamline and accelerate the preparation of instrumentation specification sheets in a modern and efficient way. Thank you for watching.